Welcome back to the Deep Dive. Today we're going into a really focused exploration of a very rare genetic condition, and this is based on the sources that you shared with us. It's called HNF1B syndrome. Some of you might also know it as MODY5. And our mission here is not just to, list off facts. It's to really understand this as a powerful case study in our genetic architecture.
It really is a perfect case study. Because when we talk about HNF1B, we're talking about a condition that hits right at the foundation. It shows how just one tiny instruction in our genetic code can, well, quietly change how critical systems like our kidneys and pancreas are built right from the start.
Exactly. And I think we should get a little technical for a moment because that's where the real insight is. The sources describe the HNF1B gene as not just, say, a building block, but more like a master switch. So what does that actually mean? When it's working correctly, what is that switch supposed to be doing?
That's a great way to put it. It's what's called a master transcription factor. The best analogy is probably the foreman on a construction site. It doesn't build the organs itself, but it controls dozens of other genes, turns them on, turns them off.
Okay.
And those are the genes necessary for the kidneys and pancreas to develop normally while in utero. So when HNF1B is mutated, that foreman is basically absent. And the organs, well, they struggle.
So if that foreman is missing, what are the primary physical results? What actually happens that we can see?
Well, it really centers on those two key organ systems. So with the kidneys, you frequently see them being small or having cysts. It's often detectable on an ultrasound, sometimes even leading to low amniotic fluid during a pregnancy.
Right, which can be an early sign.
Exactly. Then the second hallmark is the diabetes component. Because the pancreas structure is compromised, stable insulin production is difficult. And the diabetes, it typically presents slowly. It's often diagnosed later in childhood or adolescence.
Usually between 5 and 15, right?
That's the typical window.
And that delayed onset must make diagnosis incredibly difficult, especially when you factor in how rare this is. We're talking, what, maybe 1 in 100,000 kids in the U.S.?
Yeah, it's incredibly rare. And that rarity is a major hurdle. It means it often just masquerades as more common conditions. A child with high blood sugar might just be diagnosed with type 1 or type 2 diabetes at first.
And the kidney issues are seen as something totally separate.
Completely separate. Until someone connects the genetic dots. This is why awareness is so important. We need to recognize that pattern of kidney issues and early onset diabetes together.
And what about that demographic quirk the sources mentioned?
Oh, right. It's fascinating. For reasons scientists are still figuring out, HNF1B seems to be diagnosed more frequently in girls right now.
That's a huge unresolved question. So, given that this is a lifelong condition and there's no cure, the whole strategy has to be about protective management. What does that kind of proactive vigilance look like?
It's about two main goals: protecting the kidneys over the long term and maintaining stable blood sugar. And that means using the right diagnostic tools, routine ultrasounds, targeted genetic sequencing, regular glucose monitoring.
Just staying ahead of any potential issue.
Exactly. It's about being aware of the specific genetic risk to those two organ systems. That allows the clinical teams to manage diet and lifestyle choices to shield those systems for decades.
So if we connect this to the bigger picture, the research seems to be moving incredibly quickly. What's on the horizon? What future steps are scientists exploring to maybe move beyond just management?
The research is really focused on correcting the instruction manual itself. The sources highlight two really cutting-edge approaches. First, scientists are using organoids.
These are the miniature organs grown in a lab, right?
Yeah.
From patient cells.
That's right, miniature three-dimensional organs. And this allows them to test potential genetic corrections. They can see if tools like CRISPR can successfully repair the HNF1B gene blueprint, but in the lab, before it ever gets near a patient. Second, there are trials looking at things like preventive enzyme boosts, which are designed to help the compromised pancreas function more effectively.
That shift from just management to potentially repairing the blueprint is huge.
And maybe here's a final thought for you to consider. How does the precise timing of diagnosis, whether it's identified prenatally through an image or later in early childhood after diabetes starts, how does that timing fundamentally shape the strategic goals for lifelong management?
Thank you for sharing your sources and letting us dive into this intricate relationship between our genetics and the complex architecture of organ development.